So we're actually going to move on to a slight application of horizontal circular motion, and it's the thing known as a conical pendulum. So as per the name, conical implies a cone. And a pendulum is usually a timekeeping device. So you might have known of what's known as a simple pendulum. So it sort of rocks back and forth like this. Here's the normal, so these angles are the same. In a conical pendulum, the particle actually rotates around the bottom. So the string is actually slightly angled, and the particle moves around in this direction. We've actually somewhat covered a conical pendulum before in example 2. However, conical pendulums are usually suspended. So we're actually going to go through a couple of key relationships between a conical pendulum and certain physical quantities. So here we have a diagram of a conical pendulum with a string length L, radius R, and height H. So firstly, the forces up equals the forces down. So the forces up are T cos theta and the forces down are mg. So rearranging to get the tension, we get the tension is mg over cos theta. Now we also know that centripetal force is mr omega squared. So we have T sine theta equals mr omega squared. So if we put T in for T here in the second equation, we get mg over cos theta times sine theta equals mr omega squared. Now, of course, we should know at this point that sine theta over cos theta is tan theta. So we get g tan theta equals omega squared r. We can also show that tan theta is r over h, so sine over cosine. So we can either write omega as g tan theta over r per second, or by substituting in r over h, we get that omega can also be written as the square root of g over h per second. Now, the time for one revolution, I have kind of cheated a bit and used a thing from simple harmonic motion, but you can actually do this straight from omega is theta over t, but theta is 2 pi. So t is 2 pi over omega, which gives t equals 2 pi times the square root of h over g seconds. This is actually similar to the period of a simple pendulum, which we will cover in simple harmonic motion as 2 pi times root L over g per second. Or not per second, or 2 pi times the square root L over g seconds. So those are really the basic quantities you can use for a conical pendulum, and we're going to go through an example in the next video.